Hello and welcome to the Imaging Wire Show. My name is Brian Casey. I'm managing editor of the Imaging Wire. Got a great episode for you today. Our topic is AI for breast screening, and our guest is Dr. Onalisa Winblad. She is a radiologist at the University of Kansas Health System, where she currently serves as the Division Director of Breast Imaging in the Department of Radiology. Dr. Winblad, thanks for being with us today. Can you tell us a little bit about yourself?
Thanks for having me. I've been a practicing breast radiologist in Kansas for over 10 years now, and I'm looking forward to talking with you today and answering all of your questions about AI.
All right, well, let's just dive right into it then. So AI has become such a hot topic in radiology, and it's particularly hot in breast imaging. Why do you think that is?
Breast radiologists are actually very early adopters of AI. Computer-aided detection has been approved for clinical use in mammography since the late 1990s. And the use of computer-aided detection programs for mammography has really been increasing over the past few decades. So breast imagers are actually very familiar with AI, and they're very likely to be successful adopters of AI. Historically, most of our CAD products have not been largely effective, but modern advancements in all of these computer algorithms and new AI solutions have really, been wonderful. And in breast, we have very large volume standardized data sets. These are really ideal data sets for developers to use when they're kind of training these machine learning programs. So I think that's also been really helpful with AI growth and development. Just we have these very large standardized data sets that can be used. Globally and across the globe, across our country, there are concerns about the growing volumes of images that need to be interpreted, but also a radiologist shortage. We're seeing that in breast radiology across the globe, and AI has the potential to help us kind of minimize the effects of growing volumes, but with fewer people to interpret those images. So I think breast radiology is just a very ripe field for development of AI products and for utilization by radiologists who are comfortable and familiar with AI.
Yeah, I think when you think about it, breast radiologists have almost the hardest job in radiology because you've got, people have compared it to looking for a needle in a haystack. You've got all of these images, the vast majority of which are normal, but then, you've got a few cancers in there, and that's kind of what AI really, excels at, is identifying those needles in that haystack. What are some of the recent developments in AI for mammography that you think are the most exciting?
I mean, first and foremost, I think these algorithms are just becoming more accurate, and that's going to be tremendously helpful for reading those large volume, needle in a haystack, as you were saying, mammograms. Historically, a lot of these products weren't very effective, and they're becoming better and better. And I think even, looking into the future, as these products are starting to compare with prior mammograms, these algorithms are going to even get better. And that's going to allow radiologists to have better cancer detection rates, but also hopefully reduce the time of interpretation, reduce the unnecessary recalls. So I think there will be more and more benefits as these AI solutions become better and more accurate. I'm also personally very excited about AI risk stratification. So when AI can look at a mammogram and look at the patient's, breast pattern and texture and density, and looking at the mammogram patterns along with patient data, they can start to make risk predictions. How likely is it that this patient is going to develop cancer next year, in the next 5 years, in the next 10 years? This is going to just have tremendous potential and opportunity for us to use these AI tools to help triage patients and prioritize patients who need additional screening exams that are more sensitive, like breast MRI, contrast-enhanced mammography. Right now, we have such large volumes of patients undergoing screening exams. And when AI tools become really good at risk prediction, I think we're going to see completely different workflows for our patients. And that will be tremendously helpful.
And how long have you been working with AI, and what are some of the applications that you're working with?
I've been using various mammography AI tools for, the last 10 years. So of course, we've always used, at least I've always used computer, aided detection or decision support for mammography, although we've transitioned to a different product in the last year. But I've also used other AI tools. We use a breast density, software that assigns breast density to a patient's mammogram. We also use a really incredible positioning analytic, AI solution that, helps our technologists, ensure they're getting the best images with the best positioning, the lowest dose or best compression. These AI tools have incredible potential to help in just very, very different areas to make us do a better job and optimize our workflows and our programs.
The combination of breast density and AI is looking to be particularly powerful for things like, predicting risk. And there have been some really exciting studies that have come out on that. So you brought an image for us to review. Can we take a look at that?
Yeah. So this is a snapshot of an image I took from actually when we adopted Transparent AI as our new AI solution for cancer detection. This happened to be one of the very first cases we saw and found a new cancer, but it was just really a really fantastic case showing how good some of these AI tools are becoming. I've got a little yellow circle surrounding the cancer, which is very, very difficult to see on this single image. It's so incredibly tiny. But if you look on the right-hand side of the image, that's a scorecard produced by the AI solution application for us. So that just is showing the areas of interest marked by the program. And you can see that not only did the radiologist find it in this case, which was a really great call, but so did the AI tool, which is really incredible. So this is a very tiny finding. This patient went on to have a very small, surgery. This cancer was detected very early, and you can definitely see how findings such as this could be missed when you're looking at large volumes of studies, or if someone who doesn't see a lot of breast imaging studies comes across a mammogram like this, it might not be as obvious. So I think the potential applications of AI are really incredible and help us do a better job. Another really important thing to notice on this image with the scorecard is how few markings there are on the breast. Historical computer-aided detection software programs will have multiple. In fact, most radiologists who've used CAD over the last few decades find it very cumbersome and time-intensive to look at the multiple markings made by the AI tool. As these tools become more specific and reduce the number of benign findings marked on the breast, it actually allows the radiologist to more effectively use the AI tools. I know from personal experience in my program and with my colleagues, when we had a prior CAD program, we would almost many times not even, look at it or use it effectively because there were so many things on the image. Now, most of the radiologists actually want to make sure they have that scorecard available because it doesn't take much time. When there's only a few marks to look at, you're far more likely to utilize the product and have it, add to the accuracy of your interpretation than historic products that were not as accurate.
You said that the radiologist caught this particular case. I don't see how you guys do. I don't see how you guys do it. I look at that and it's just like, wow,
We do this amazing every day, so we get really good, and we have other tools and things on our real workstations. So that's just a snapshot, but it's really tricky. We are, like you said, at many times looking for a needle in a haystack. So
yeah, you guys do amazing work. So you mentioned a little bit earlier about using AI to help with patient positioning, and so that's a little bit different from some of these point solutions that analyze image data. But it's turning out that AI is having a really important role in improving workflow. Can you talk about what some of these workflow improvements are doing for you?
Yeah, absolutely. You're correct. We've actually found some of the workflow improvements, from AI are actually some of the most helpful in our practice. We are using a positioning analytics software, and what this does on every single mammogram that's obtained, it individually per technologist, it's going to use AI to look at positioning of the breast on the image. It's going to look at the dose, the compression, and then it creates all of these essentially outcome audits for the technologist with specialized, training in certain areas. If certain areas need improvement, it will help benchmark them against, themselves, each other, people across the country. And it really helps us kind of schedule our technologists, to the most optimal workflow and work with people who are good in something and people who might be better at this. And it's been really effective, and our technologists are phenomenal and their positioning is outstanding. And tools like this only help us to get better and better and train more and more technologists to do an amazing job as well.
Are you seeing workflow benefits for the radiologists who are doing the interpretation from some of the image analysis AI tools?
So absolutely. So from a workflow standpoint, in regards to some of our software, we actually use it to triage our patients, both for exams that are occurring in our office and in research studies before the radiologist has even interpreted the mammogram. This is incredibly helpful for breast density workflows. So if a patient's scheduled for a supplemental screening test for dense breast tissue following their mammogram, if their breast density assessment shows the patient is in fact dense, the patient, instead of waiting for a radiologist to read the mammogram, they could be in a procedure, doing a biopsy, they could be talking with the patient. This actually allows good patient throughput. They can immediately go to the next study, and those can be dictated, after the second study is done. This is used for our research studies when we have mammogram density, volume, other data. This actually allows some of our patients in prevention trials in our program to be triaged to certain arms of the study. We, in regards to our transparent AI, we actually do not use the work list prioritization function, although that's incredibly helpful for some practices. So there's lots of different benefits. It truly depends on how you need to use AI to be effective and the environment in which you're practicing.
Now you handle a high-risk population. Do you see the value of AI being different compared to a more conventional mix of patients?
Absolutely. So you're correct. We have a large volume of high-risk patients in our cancer program, several high-risk prevention clinics and trials going on. And I think AI is going to be tremendously helpful in these populations. Of course, our high-risk patients and our patients with dense breast tissue are more likely to have aggressive cancers. They're more likely to have cancers missed on mammogram. So improved cancer detection support for these patients, as well as improved risk prediction models, are going to be critical for this patient. It's going to change the way that we evaluate these patients. It's going to change the way that we can triage these patients and ensure, which patients are going to benefit the most from these extra screening exams like breast MRI, contrast enhanced mammography. If we have better risk prediction models, this really has potential for tremendous impact on this population.
Do you ever have conversations with your patients about the use of AI to analyze their mammograms? And if so, what are their reactions?
I don't have consistent and dedicated conversations with our patients or providers. However, those conversations have occurred several times. And most of the time people are, I think most of the time people are actually very receptive to us using AI tools. I think people and providers are being more comfortable with AI as they are also increasingly utilizing different AI tools in their own lives for different things. I think people are becoming more comfortable with it. I always talk to patients and providers and remind them that the radiologist is still interpreting your image. And in fact, they also have to interpret the AI tool. So if anything, you're getting an even better more accurate interpretation of your study by using this tool. So most people think it's wonderful.
Yeah. And there's been so much research published, just in the last year on how effective these tools are. So I think that if anybody did have concerns about, AI looking at mammograms, it's just, it's an additional, it's kind of an additional reader. And as you mentioned earlier, computer aided detection has been reviewing mammograms for, I think, over 20 years, something like that. Yeah. How did the implementation go at the University of Kansas of AI for mammography? Any lessons from that you could share with our audience?
Yeah, our implementation went well. This was very easy for the radiologists to learn how to use. It was very easy to adopt into our normal workflow. A few things that we had to deal with initially. AI solutions take time to analyze images. So we learned after implementing this solution that when the screening mammogram, for instance, comes over to my workstation into our reading work list, it might take a few minutes for the AI, to analyze and provide a scorecard. So we had to adjust our workflows a little bit just to make sure that the scorecard was available at the time of our interpretation. When we first implemented Transpera, we have, as I told you, have a very large high risk population. Some of our referring providers were concerned about the low, intermediate, elevated terminology or phrasing on some of the scorecards. They didn't want that to get confused with, patient risk. They didn't want to receive potentially questions about cases where maybe the radiologist interpretation did not align with the scorecard. I was really thrilled with this. Is a very easy solution. We actually were able to remove some of that phrasing, which in our academic center with a strong high risk prevention program, we were able to get rid of that phrasing, and we adopted the numeric value that grades the exam. So it gives you a 1 through 10 score. And to the radiologist, that was still very meaningful and didn't change the interpretation for us at all. But it made it a little bit easier for our referring providers and patients who may see the scorecards. It made it a little bit easier for them to adopt as well. And we actually, interestingly, saw the same concern or worry from our providers when we adopted breast density software several years prior. So I kind of anticipated that and expected that. And it was thankfully a very easy solution. And that being said, it's really important that you have vendors who are willing to work with you and change products for you and how they're used, because different practice environments are very different. And you may need to use a tool very differently than someone in another practice. And so we've been able to really implement this, in a successful way that's been easy to adopt for everyone.
Great. Do you have any other advice for facilities like the University of Kansas or not like the University of Kansas in terms of implementing AI for breast screening?
Well, I would my words of wisdom are truly that you need to assess the practice, the program that you're in. Really think about what tools are going to help you in your practice. Where are some areas for improvement? Is it quality? Is it workflow improvement? And then really seek out products and vendors that have tools that are going to help you. Evaluate multiple products, select the best product that fits your needs. Most importantly, make sure that any AI product that you choose is validated on large, diverse populations and data sets, and use a product that's going to be continually updating the algorithm so that it's the best product it can be for years to come. And most importantly, too, once you have a product in place, measure outcomes, determine, is this product working as it should? Is it accurate in my breast program? Is it safe? Does it provide value? Is it cost effective? We are in the first year of utilizing our new AI solution, which is exciting because after a year, we can do a true medical audit, look at our performance pre and post implementation of this AI solution, and see, has it helped us find more cancers? Has it reduced our recall rates? Has it, do we have better outcomes? Are we reading exams faster? Are we able to get more volumes in the same amount of time? So I'm really excited to see if we've demonstrated improvement in our own program.
What are you looking forward to seeing in mammography AI in the next year? I mean, last year was such a watershed year for so many important clinical studies. What do you think that we have coming up?
I think I'm most excited for these algorithms and machine learning tools to be analyzing the patient's prior mammogram. I think we need our AI solutions to be even more sensitive and specific, meaning the radiologist doesn't want to look at a bunch of benign, unnecessary things. And we want our scorecards to be more accurate. The more comfortable we get with our scorecards and the more accurate they are, we're going to be able to reduce our interpretation times, and programs that need to use second readers or other, solutions to read large volumes are going to be able to significantly improve their workflows. I'm truly looking forward to some of the new exciting risk prediction solutions that are going to be coming. When these AI solutions are going to look at the mammogram itself and help us determine how likely it is that a patient is going to have cancer in the next 1 to 5 years. Historically, we do this with risk prediction models. So we put in the patient's age, their family history, other important factors that give us kind of an ideal risk assessment. What's their lifetime risk? And that's how we triage patients to get a breast MRI when it's necessary or another screening test. I think when we have really great AI solutions that look at the mammogram itself, the breast texture, density, add all of these things together and perform really great risk predictions, it will completely change our workflows for breast cancer screening and personalized screening, which is where we need to go.
Well, it's really going to be exciting to see where things develop here. So, yeah. Oh, some great discussion today. I'd like to thank Dr. Onalisa Winblad of the University of Kansas for being with us. Thanks for your time, Dr. Winblad.
Thank you.
All right, signing off for the Imaging Wire, my name is Brian Casey.